On September 1943, they carried the same tactical handbook every mortar crew had used since World War I. The doctrine was simple, and it had worked for decades. You set up your mortar, you looked at your target, and you dropped rounds on it. Direct observation, line of sight. If you couldn't see the enemy position, you moved until you could. That's how mortars had always operated. From the trenches of Verdun to the deserts of North Africa, then they saw the mountains. The Apennine range cuts through Italy like a spine, and the Germans had fortified every peak, every ridge, every impossible cliff face. American commanders quickly realized they had a problem that no training manual addressed. Your mortar team would be in a valley. The German machine gun nest would be 2,000 left above you, tucked behind a rock formation on the reverse slope of a mountain. You physically could not see it. Moving closer didn't help because the mountain itself blocked your view. Climbing the mountain to get line of sight meant hauling 60 lb mortar tubes up near vertical terrain while German snipers picked you off. The 34th Infantry Division learned this the hard way at San Pedro and Fine in December 1943. There, mortar platoons set up in the valleys below Mount Samagro trying to support the rifle companies climbing toward German positions. The spotters reported enemy bunkers firing down on American troops. But when the mortar teams looked up, all they saw was rock and sky. They fired anyway, guessing at angles and charges. Most rounds exploded harmlessly against cliff faces or overshot into empty valleys beyond. The few that landed near German positions did so by pure chance. After 5 days off fighting, the 34th Division had suffered over 1,000 casualties and their mortars had been nearly useless. Traditional mortar doctrine assumed terrain that was relatively flat or gently rolling, where you could observe your target from your firing position or from a spot just a few hundred yards away. The 31mm M1 mortar had a maximum range of about 3,000 yards and was designed for direct support of infantry attacks across open ground. In France during World War I, you'd set up behind your front line, watch enemy trenches through binoculars and adjust fire based on what you saw. In the North African desert, the same principle applied. Fast sightlines meant you could usually see what you were shooting at, or at least see the dust your rounds kicked up when they landed. But Italy's mountains created blind zones everywhere. A German position might be only 800 km away in straight line distance but separated from you by a mountain ridge that rose 1,500 km. You couldn't see over it. You couldn't see through it. And the Germans had deliberately positioned their defensive lines to exploit these blind zones, placing their strongest positions on reverse slopes where American mortars and artillery couldn't observe them from below. Wehrmacht tactical doctrine called this hang-still slope positioning, and it turned every mountain into a fortress. By January 1944, after 3 months of brutal mountain warfare, American casualties were mounting, and ground gains were measured in yards per week. Officers were reporting the same problem up and down the Italian front. Our mortars can't hit what they can't see, and they can't see anything. Something had to change, or the Italian campaign would grind to a bloody stalemate. The solution would require throwing out decades of mortar doctrine and inventing an entirely new way to fight. The answer came from Lieutenant Colonel Russell W. Volkmann, who'd spent 1942 fighting Japanese forces in the Philippines and had watched how indigenous scouts would climb to high ground to direct mortar fire. When he joined the 85th Infantry Division training for Italy in early 1944, he pushed a radical idea: split the mortar team. The gunners stay in the valley where they're protected and can resupply. The observer goes up the mountain, where he can actually see the target. The concept wasn't entirely new. Artillery had used forward observers since the late 1800s, but mortars were different. Mortars were infantry weapons organic to the rifle company, designed to be with the troops they supported. The whole point was immediate responsive fire. Separating the observer from the gun seemed to violate the fundamental nature of mortar operations. But nothing else was working. The U.S. Army began training dedicated forward observers in February 1944 at the Infantry Training Center in Naples. These weren't going to be typical soldiers. A forward observer had to read maps like a seagrafer, calculate coordinates like a mathematician, and communicate under fire like a radio operator. He also had to climb mountains while carrying a 30 lb radio, binoculars, maps, a compass, and often a rifle. Physical fitness wasn't optional. Staff Sergeant William Bradford from the 88th Infantry Division described the selection process in his after-action report from March 1944. Out of 40 volunteers from his battalion, Only 12 made it through the 2-week course. The washout rate wasn't about toughness. It was about math. Forward observers had to convert what they saw through binoculars into 6-digit grid coordinates, then calculate the deflection and elevation the mortar crew would need to hit that spot. From apposition, the observer couldn't even see. Get one number wrong and your rounds land on your own troops. The training was brutally practical. Observers would climb Mount Vuvius with their radios, then direct practice fire from mortar teams positioned at the base who couldn't see the impact area. The observer would identify a target, say an abandoned German half-track on the northern slope, call the coordinates to the gunners below, and then walk their fire onto the target using only radio commands. Add 50, right 20. The mortar team would adjust, fire again, and wait for the observer's correction. It took dozens of rounds to develop the rhythm. By March 1944, every American infantry regiment in Italy had forward observer teams integrated into their mortar platoon. The typical setup was one observer for every 2 mortar tubes. Though in heavy fighting you might have multiple observers working different sectors, the observers moved with the rifle companies during attacks, always trying to get to high ground where they could see German positions that remained invisible to everyone else. Private First Class Robert Kafir was a forward observer with the 1st Infantry Division and kept a detailed diary of his work during April 1944 in the Fuda Pass area. His entry from April 18th describes climbing to an observation post at dawn, spotting a German mortar position firing on American troops from behind a ridge 1,500 yards away, and radioing coordinates back to his gun crew in the valley below. They couldn't see the Krauts and the Krauts couldn't see them, but I could see both, he wrote. Felt like I was playing chess with real pieces. That's exactly what it was. The forward observer had become the essential link in a new kind of warfare, where seeing and shooting were separated by mountains and miles. The observer could see the target. The mortar crew could not. Between them was a radio connection and a problem that came down to pure mathematics. The crew needed 3 numbers to hit anything: deflection, elevation, and charge. Get those 3 numbers right and your round lands on target. Get them wrong and you're wasting ammunition or killing your own men. Deflection came first. The M1 mortar had a traversing mechanism marked in mils, a military angular measurement where 6,400 millimeters equal a full circle. The gunner would set his mortar tube to 0 MNs pointing at a reference point, usually a distinctive terrain feature everyone could identify, like a lone tree or a destroyed building. When the observer radioed target coordinates, the Fire Direction Center would plot both the mortar position and the target position on a gridded map, then calculate the angle between the reference point and the target. If the target was 847 misses clockwise from the reference point, the gunner would traverse his tube exactly 847 minutes right. The math got more complex with elevation. An 81mm mortar could fire at angles between 45 and 85 degrees, and choosing the right angle depended on range and obstacles. The M1's range tables printed on cards that every gunner carried showed that to hit a target 200 degrees away, you could use 67 degrees of elevation with charge 4 or 52 degrees with charge 6. The higher angle meant a steeper trajectory that could clear nearby ridges, while the lower angle gave you a flatter arc that was faster, but might hit an intervening obstacle. Here's where it got tricky. In the mountains, your map would show the target at 1/200 YD horizontal distance, but what if that target was also 400 of higher in elevation than your mortar position? You weren't really shooting 200 YD. You were shooting up a slope. The actual line of sight distance was longer, maybe 1,280 yards. Fire Direction Corporal James Chen from the 10th Mountain Division described this calculation in a training memo from March 1944. We'd use the Pythagorean theorem. Horizontal distance squared plus vertical distance squared equals actual distance squared. Every mission in the mountains required that calculation. The charge selection determined how much propellant would launch the round. The M1 used incremental charges, small fabric bags of powder that attached to the base of the mortar shell. Charge 1 was minimum power for close targets. Charge 6 was maximum for distant ones. The range tables told you which charge to use for which distance, but altitude changed everything. Thinner air at higher elevations meant less resistance, so a round fired with charge 4 at sea level would travel farther than the tables. Predicted when fired from a mountain position at 3,000 FT elevation. Experienced crews learned to subtract about 50 yards of range for every 1,000 FT of altitude. Then came the weather variables. Temperature affected propellant burn rate. The same charge in freezing conditions produced less velocity than in warm weather. Wind pushed rounds off course and mountain winds were chaotic, swirling in different directions at different altitudes. A round fired up a valley might encounter a crosswind at 500 wide altitude that didn't exist at ground level. Observers had to estimate wind speed and direction at the target's altitude and radio corrections. Technical Sergeant Arnold Fitzgerald's fire direction notebook from the Rapido River fighting in January 1944 shows a typical calculation. Target grid coordinates 892437. Mortar position 889433. He calculated deflection at 450 miles from reference point. Range at 1340 wide with 280 ft. Altitude gain actual distance 1380 yd. He selected charge 5 with 61 degree elevation. First round landed 40 yards over. The observer radioed drop 40. Fitzgerald reduced elevation by 2 degrees. Second round hit. All those calculations meant nothing if the observer couldn't communicate them. A forward observer sitting on a mountain peak watching German positions was useless, unless he could get accurate information to the gun crews below. In early 1944, the U.S. Army issued a radio that would make indirect mortar fire actually possible, the STR-300. The Signal Corps Radio 300 weighed 38 LABs with its battery pack and could transmit voice communications up to 3 minutes under ideal conditions. In the mountains, ideal conditions didn't exist. The SCR-300 operated on FM frequencies between 40 and 48 MHz, which meant it worked on line-of-sight transmission. Radio waves at those frequencies don't bounce off the atmosphere or bend around obstacles. They travel in straight lines. If a mountain blocked the path between the observer and the mortar crew, the signal died. That's why forward observers always tried to reach the highest ground possible. Staff Sergeant Donald Pierce from the 85th Infantry Division explained the positioning challenge in his April 1944 report. I needed to see the target and have line of sight to my gun crew. Sometimes that meant climbing an extra 200 ft past where I could see the cruts, just to get my radio signal over the ridge between me and my boys. Radio communication range could drop from 3M to 300 yd if terrain interfered. The radios ran on BA-70 batteries that lasted about 12 hours of continuous use. Maybe 24 hours if you were careful. In winter conditions, battery life dropped to 8 hours because cold reduced chemical efficiency. Observers carried spare batteries, but each battery weighed 3 lb. Carry 4 spares and you'd added 12 lb to the 38. You were already hauling up a mountain. Weight calculations became survival calculations. The Germans knew the American forward observers used radios and they hunted them aggressively. Radio direction finding equipment could locate a transmitting radio within a few hundred yards, and German snipers were trained to watch for the distinctive whip antennas of the SC-300. In after-action interviews, multiple observers reported taking fire within minutes of beginning radio transmissions. Private First Class Leonard Shaw from the 88th Infantry Division described being pinned down by sniper fire on Monte Battaglia in September 1944 while trying to call fire missions. I'd key the mic, give my coordinates, and immediately rounds would crack past my head. The sniper knew what that radio meant, so observers developed communication protocols that minimized transmission time. Instead of conversational exchanges, they used standardized brevity codes. A typical fire mission would sound like this. Fire mission grid 847293 infantry and open will adjust. Over. The gun crew would acknowledge shot over, meaning they'd fired. The observer would watch the impact and respond with a correction. Right 50, add 75. Over. The entire exchange might last 30 seconds of transmission time, but mistakes in radio communication killed people. During the Anzio breakout in May 1944, a forward observer with the 34th Infantry Division called a fire mission and transposed 2 digits in his grid coordinate. He said grid 892437 when he meant grid 829437. That's a difference of 6,000. That his mortar platoon fired 6 rounds at the wrong coordinates before the observer realized his error. Those 6 rounds landed in a rear area where American engineers were clearing mines. 2 engineers died and 4 were wounded because 1 number got switched during a radio transmission. The pressure on forward observers was immense. You're on a mountain under enemy fire using a radio that might fail or draw snipers, calling corrections for mortars you can't see, trying to hit targets that are killing your friends. And every number you transmit has to be perfect. Monte Cassino was where theory became proof. The ancient monastery sat atop a 1,700 ft mountain, dominating the Liri Valley, and the Germans had turned the entire massif into a fortress. The Gustav line defenses included bunkers blasted into solid rock, machine gun positions with interlocking fields of fire, and artillery observers who could see every American move across the valley floor. The Allies needed to take Cassino to advance on Rome, and they needed it badly. The First Battle of Cassino began on January 17, 1944, when the 34th Infantry Division attacked up these slopes. Their mortar platoon set up in the valley near the Rapido River, and immediately the crews realized they couldn't see anything they needed to hit. German positions were on reverse slopes behind ridges inside caves. The forward observers went up with the rifle companies, climbing into positions where they could finally see what needed to die. Second Lieutenant Frank Merchant's observer team from the 168th Infantry Regiment established an observation post in Hill 56 on January 24th, giving them a view of German bunkers on Monte Castellone's northern face. These weren't field fortifications. These were enforced concrete structures with walls 3 ft thick, built into the mountainside with only their firing slits visible. Merchant could see them clearly from his position. The mortar crews 2,000 yards behind him in the valley couldn't see them at all. Merchant radioed coordinates for a bunker complex at grid reference 8734512. The Fire Direction Center calculated deflection and elevation, factoring in the 900 ft altitude difference between the guns and the target. At 14:35 hours, the first ranging round fired. Merchant watched it land 75 wide short and to the left. At 75 left 50, he transmitted. The crew adjusted. The second round hit within 20 yard. Fire for effect. 4 mortars began sustained fire, walking rounds directly into the bunker complex. After 37 rounds, the Germans stopped firing from that position. This was happening across the entire Cassino front throughout late January and February. The 36th Infantry Division's mortar platoon were hitting German observation posts they couldn't see on Monastery Hill. The 4th Indian Division's American-equipped mortar teams were destroying German strongpoints on Point 593 using corrections from observers positioned on Castle Hill. The TIE system worked because the observers could see what the gunners could not. Technical Sergeant Carl Zimmerman from the 133rd Infantry Regiment kept detailed records of his mortar platoon's effectiveness during February 1944. Before implementing the forward observer system, his 4 tubes averaged 16 rounds per confirmed target hit, mostly luck and saturation fire. After integrating trained observers, that dropped to 4.2 rounds per hit. They were using less ammunition and killing more Germans. On February 11th, his platoon engaged 23 separate German positions over a 7-hour period, all of them invisible from the gun line, all of them destroyed or neutralized using radioed adjustments. The Germans noticed Wehrmacht battle reports from February 1944, captured after the war repeatedly, mentioned unexplained accurate American mortar fire from positions with no observation. A report from the 1st Parachute Division dated February 18th states, enemy mortar fire continues to strike defensive positions with high accuracy despite complete concealment from enemy valley positions. Counter-B fire ineffective as American mortars displace after each mission. The destruction of the Cassino Monastery itself on February 15, 1944 came from heavy bombers, but the weeks of fighting afterward showed how effective the indirect mortar system had become. During the Third Battle of Cassino in March, American and Allied mortar teams fired over 75,000 rounds at targets they never directly observed. Forward observers directed every mission, adjusting fire onto German positions that had been considered untouchable just 4 months earlier. Staff Sergeant Raymond Parker from the 351st Infantry Regiment summarized it in his after-action report from May 1944. "We proved you don't need to see the enemy to kill him. You just need someone who can see him and a radio that works." The interrogation reports tell the story better than any American after-action report could. When Allied intelligence officers questioned captured German soldiers from the Cassino battles, the same confusion appeared again and again. A corporal from the 3rd Parachute Regiment captured on March 23, 1944, told his interrogators, "We were in a bunker on the reverse slope. The Americans in the valley could not see us. This we knew for certain, yet their mortars landed directly on our position, not random fire, precise hits. We could not understand how that confusion ran up the German chain of command." A battle assessment from General Lieutenant Fridolin von Unger und Etterland, commander of 14th Panzer Corps defending Cassino, noted in April 1944 that American mortar accuracy had exceeded what terrain analysis suggested was possible. German doctrine assumed that if you couldn't see the enemy couldn't effectively target you. The Americans had broken that assumption, and German defensive planning hadn't caught up. Obergreiter Klaus Becker from the 71st Infantry Division, captured near MNO in May 1944, described his unit's experience to Allied interrogators. His machine gun team had been positioned in a natural cave on Monte Cassino's northern slope, completely invisible from American positions below. "We felt safe there," he said. "No American could see our position." But on May 17th, mortar rounds began falling at our cave entrance. Not searching fire, direct targeting. 3 rounds very close together. We had to abandon the position. We never understood how they knew we were there. The answer, of course, was that an American forward observer on a different peak had seen them perfectly. German soldiers began reporting sightings of American troops in exposed positions on high ground, always carrying radios with long antennas. Wehrmacht snipers were ordered to prioritize these targets, but the Americans had learned to position their observers in protected spots with good cover. A directive from the German 1st Parachute Division dated April 3, 1944 instructed, "Enemy forward observation teams equipped with radio apparatus are directing mortar fire. These teams must be eliminated to reduce mortar effectiveness." The directive acknowledged the Germans had identified the system, but by then it was too late to matter. Hauptmann Ernst Weber commanded a company in the 44th Infantry Division and was captured during the Anzio breakout in late May 1944. His interrogation transcript includes a remarkable admission. "We knew the Americans were using radio-equipped observers, but we could not believe they could calculate firing data accurately without direct observation of the gun line. We assumed their fire would be imprecise. It was not imprecise. It was very accurate. This was not what we expected from American troops." That last comment reflects a broader German miscalculation. Wehrmacht tactical doctrine in 1944 still assumed American forces were poorly trained and relied on material superiority rather than tactical skill. The indirect mortar fire system proved that assumption wrong. This wasn't about having more equipment. This was about innovative tactics executed by well-trained specialists working together. German attempts to counter the system mostly failed. They tried jamming American radio frequencies, but the SCR-300's FM transmission was harder to jam than AM systems. They increased counter-batter fire, but American mortar teams had learned to displace immediately after firing missions, making counter-batter work nearly impossible. They tried infiltrating snipers to hunt forward observers, but the observers operated with infantry protection and were hard to isolate. A German tactical bulletin from June 1944 captured near Grostow included this assessment. American indirect mortar fire doctrine represents a significant tactical innovation. No effective countermeasure has been identified. Units should assume all positions are observable regardless of terrain masking. The Germans had adapted their doctrine to accept a reality they still didn't fully like. The Americans could hit what they couldn't see, and there wasn't much anyone could do about it. By summer 1944, what had started as an experimental solution in Italy had become standard operating procedure for every American unit facing mountain terrain. The techniques weren't staying in Italy. They were spreading across every European theater where mountains created blind fire problems. The 3rd Infantry Division brought indirect mortar tactics to southern France during Operation Dragoon in August 1944. When they hit the Maritime Alps and the Vosges Mountains, their mortar platoon already knew how to operate with separated observers. The 36th Infantry Division, blooded at Cassino, carried the same doctrine into the Vosges in October. By the time American forces were fighting through the Vosges Mountains toward the Rhine, every infantry regiment had forward observers trained in the Italian system. The terrain in the Vosges wasn't as dramatic as the Italian Apennines. Peaks averaged 2,000 to 3,000 FT rather than 5,000, but the thick forest created the same observation problems. German positions tucked into tree lines on reverse slopes were invisible from American gun positions in the valleys below. The 100th Infantry Division, fighting through the Vosges in November 1944, reported that 73% of their mortar missions were conducted without direct observation of the target. Forward observers were essential. The U.S. Army Infantry School at Fort Benning updated its mortar training curriculum in September 1944 to make indirect fire doctrine the primary instruction method, relegating direct fire to a secondary technique for special situations. The New Field Manual FM 7290 published In October 1944, dedicated 40 pages to forward observer, procedures and indirect fire calculations. Training time for mortar crews increased from 3 weeks to 5 weeks to accommodate the additional technical skills required. The 10th Mountain Division represented the full maturation of the doctrine, formed specifically for mountain warfare and trained at Camp Hale, Colorado at 9,200 FT elevation. The 10th integrated indirect fire tactics from day one of training. Their mortar platoon trained with forward observers in the Rocky Mountains throughout 1943 and 1944, perfecting the coordination before they ever deployed to Italy in January 1945. When the 10th Mountain Division attacked German positions in the northern Apennines in February and March 1945, their mortar effectiveness was extraordinary. During the assault on Riva Ridge on February 18, 19, forward observers directed mortar fire onto German positions from peaks the observers had climbed at night. The gun crews were in valleys 4 miles away and couldn't see anything but mountains. The operation succeeded partly because German positions that should have been invulnerable were destroyed by mortars firing blind. Statistical analysis from VCOR's headquarters in March 1945 showed that mortar effectiveness measured in rounds, expended per target, neutralized had improved by 68% since January 1944. The average time from observer request to first rounds on target had dropped from 12 minutes to under 4 minutes. These weren't minor improvements. This was a fundamental transformation in how mortars operated. The British and Canadian forces operating in Italy adopted similar tactics after observing American methods. The British 78th Infantry Division integrated forward observer teams into their mortar platoon in spring 1944. Canadian units fighting in the Liri Valley implemented the system in May 44. By the end of the Italian campaign, indirect mortar fire with separated observers had become Allied doctrine, not just American. French forces equipped with American weapons after Operation Dragoon received training in indirect fire methods from U.S. Army instructors. In September and October 1944, the French 1st Infantry Division used these tactics during their advance through the Vosges and later in the Alpine passes, near the Italian border in April 1945. By the time Germany surrendered in May 1945, blind mortar fire wasn't experimental or innovative anymore. It was just how mortars worked in mountain warfare. A system invented out of desperation in Italian valleys had become fundamental doctrine across every Allied army fighting in Europe. The principles those World War II mortar teams developed didn't fade after 1945. They became the foundation for every indirect fire system that followed. When the U.S. Army rewrote its artillery and mortar doctrine in the 1950s, these paraded observer and blind fire calculations remained central. The technology improved, but the fundamental concept stayed exactly the same. Korea proved the system's durability. When American forces fought through Korean mountains in 1950 and 1951, they encountered the same observation problems Italian peaks had created. Forward observers climbed ridges to spot North Korean and Chinese positions on reverse slopes, radioed coordinates to mortar crews in protected valleys, and directed blind fire onto targets the gunners never saw. The SCR-300 radio had been replaced by newer models, but the tactical employment was identical to what had worked at Monte Cassino. Vietnam introduced jungle canopy that created observation problems as severe as mountains had. Forward observers couldn't see through triple canopy rainforest from ground level, so they operated from hilltops or even from helicopters, directing mortar and artillery fire onto enemy positions concealed below. The calculation methods had been refined. The radios were lighter and more reliable, but the doctrine traced directly back to 1944 Italy. Modern technology enhanced the system without replacing it. Laser rangefinders eliminated some of the manual distance calculations that World War II observers had done with maps and compasses. A forward observer in Afghanistan in 2007 could point a laser at a Taliban position, get an instant grid coordinate readout, and transmit that digitally to the gun line. But the fundamental relationship remained unchanged. Observer sees target, gunner does not. Accurate fire happens anyway. GPS added precision that 1944 observers could barely imagine. A modern mortar crew knows its exact position within 10 meters, and the fire direction computer calculates deflection and elevation automatically. But someone still has to see the target and someone still has to adjust fire onto it. The mathematics got faster, not different. An 81mm mortar in the Korengal Valley in 2009 was still firing on parabolic trajectories calculated from observer input, hitting Taliban positions the gun crew couldn't see, using principles developed 65 years earlier. The wars in Iraq and Afghanistan saw American mortar teams engaging targets in mountainous terrain that would have looked familiar to veterans of the Italian campaign. Forward observers with the 10th Mountain Division, the same division that had perfected indirect fire in the northern Apennines in 1945, operated in the mountains of eastern Afghanistan in the 2000s, using direct doctrinal descendants of their predecessors' methods. The technology in their hands was advanced beyond anything World War II soldiers could have imagined, but the tactical concept was identical. Field Manual 32290, the current U.S. Army mortar manual published in 2011, dedicates its longest chapter to indirect fire procedures and forward observer operations. The diagram showing observer-gunner separation and the formulas for calculating firing data are more sophisticated than the 1944 versions, but a mortar sergeant from Monte Cassino could read the modern manual and recognize everything in it. The core hasn't changed because it didn't need to change. The solution those desperate crews invented in Italian mountains was fundamentally correct. Today's precision-guided munitions and drone-directed strikes represent the ultimate evolution of the see-a-shoot separation that World War II mortar teams pioneered. When a drone operator in Nevada directs a missile onto a target in Syria, the principle is the same. The observer and the weapon are separated, sometimes by thousands of miles instead of thousands of yards, but the concept remains identical. Someone sees the target, someone else delivers the fire. Mathematics and communication make it work. Those mortar crews in Italy during 1944 weren't just solving an immediate tactical problem. They were inventing the future of indirect warfare, creating methods that would define military operations for the next 80 years, and counting. Every artillery mission, every mortar strike, every precision weapon delivered by an operator who can't see the gun, all of it descends from those teams who learned to kill what they couldn't see.